Hello there. For networking, we need to understand some numbering systems because we're going to be looking at addressing in a variety of ways. And depending on the address, it might be in decimal, it might be in hexadecimal, it might be in binary. So let's have a look at what we have to deal with. The main numbering systems, as I've just mentioned, are decimal, which is great for us fleshy brains. And then you've got binary, which is great for the silicon brains. And then we have hexadecimal, which as far as I'm concerned is a compromise between the two brain types. So let's jump into a numbering system that we're already familiar with and explore it a little bit. So let's start out with decimal, where des means 10 in Latin, I think. Correct me in the comments if I'm wrong. But we have 10 values to work with. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And, as with most numbering systems, where we position these values will affect the numerical value we are trying to represent. Now, as patronizing as this might feel, just humor me for a little bit while we go back to your early school days and look at the decimal numbering system like your school teachers would have taught you. So we're going to start with 1. We always start a numbering system with 1 if we're going to do these columns that help us keep track of what value we're representing. Now that we have 1 to start with, we multiply by the number of numbers in the numbering system. Wow. How many times do you think I can say numbers in one sentence? So 1 times 10 is 10, 10 times 10 is 100, 100 times 10 is 1,000, so on and so forth. Now if we make these the value of our columns, we can then start sticking the decimal values in there. Any of those 10 values we want. If I put an 8 there, it means I've got 8 ones or just 8. If I put under the tens column an 8 and a 0 under the ones column, it means I've got 8 tens and no ones, which is how we write 80. Then, if I do 802, I've got 8 under the 100, 0 under the 10, and 2 under the ones. And finally, if I put an 8 under the 1,000, a 0 under the 100, 2 under the 10s, and 3 under the 1s, I've got 8 1,000s, 0 100s, 2 10s, and 3 1s, or 8,023. Now, one thing the school teachers don't normally show you is these little exponent things that sit above the value of each column. So we put 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, and 10 to the power of 3. Now, the base value of the exponent is going to be the number of numbers in the numbering system. And then we go from right to left, 0, 1, 2, 3. Position 0, position 1, position 2, position 3. Now, I know some people might not be very strong with maths, but still want to get into IT and networking, and that's fine. Let's take a quick detour for exponents. If you're already comfortable with how exponents work, you can skip ahead to the next section. The timestamps are down below in the description. But for those of you who just want a quick recap on how exponents work, this is what we have. You've got the base value, and as a superscript or small text written above, you've got the exponent. And all it means is it's the base value multiplied by the base value, multiplied by the base value, exponent number of times. So if I say I've got 3 to the 4, it means I'm doing 3 times 3 times 3 times 3, which is 81. So if that was a bit heavy for you, well, you can break it down, because 3 times 3 is 9. If we take 9 and times it by 3, that gives me 27. If I got 27 and times it by 3, that gives me 81. Now the good news is, there are some little quick rules we can apply here. Like for example, if we have anything to the power of 0, it is always equal to 1. End of story, no matter what x is. X could be 7, x could be 32,768. If you put it to the power of 0, it's equal to 1. Then, x to the power of 1. Anything to the power of 1 is equal to itself. Only when we start doing anything to the power of 2 do we actually start seeing the base value being multiplied by itself that many times over. So x squared, or x to the power of 2, is x times x. X cubed, or x to the power of 3, is x times x times x. X to the 4 is x times x times x times x. Rinse and repeat, right? So hopefully that made that extra row a little bit easier for you. Now for those of you who have skipped ahead, welcome back. Let's move on to binary now. So we have to deal with binary at some point when it comes to networking. At the very least, we're going to be looking at it for subnetting, which we're going to be looking at in a video very, very soon. Now, bi means 2 in Latin. Again, if I'm wrong, please correct me. But that means we've got two values to work with, 0 and 1. And just like decimal, the position we put these numbers in affects the value we're representing. Now, I personally believe that binary should actually be easier than decimal. The reason being, with decimal, you've got 0, which means you don't want to use the value of a column. And then you've got 1 through to 9, where you say you do want to use it a certain number of times. With binary, it technically, in my mind at least, is easier because you've got 0, I don't want to use this column, or 1, yes, I do want to use it, and I'm only going to use it once. So I personally believe that if we were taught binary since we were little kids, we would probably be able to count in this way easier than we could in decimal. But hey, you know what? Decimal's drilled into our heads since we're very young, so I suppose it becomes intuitive, right? So because of that, we're going to use decimal to understand binary, I'm afraid. But we'll get very close to thinking like a computer, I promise you that much. So let's check it out. So we're going to start this little conversion table with 1. We're always going to start a numbering system with a 1 column all the way on the right-hand side. And just like the decimal system where we kept going times by 10, times by 10, times by 10, here we're going to go times by 2. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, 64 times 2 is 128, 256, 512, 1024. Wow, these numbers are looking a little bit familiar if you've ever played around on your computer, right? Because remember, your computer is a binary device, so you're always going to see multiples of 2 somewhere. Now, because my main intention with the binary is to help you get used to IP version 4 and subnetting, I honestly only really need columns 1 through to 128. With that, I can handle each octet of an IPv4 address. So let's keep it simple and compact for now. So let's put a nice little row there, throw some column lines in there, and we better do some exponents above the numbers here. So base value, as I said, is the number of numbers in the numbering system, which is going to be this time 2. And rightmost column is 2 to the 0, which is 1. Then we're going to have 2 to the 1, which is 2. 2 to the 2, which gives me 4. 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7. Now, when you're tackling the Network Plus exam, or actually, you know what, any networking exam where you might need to do this, it can be very, very helpful to quickly jot this table down so that you can easily convert between decimal and binary when you need to. So now that we've got a conversion table going, let's play with it now. Here's a binary value, 10101000. So now we're going to convert it. And I'm going to do it the horrible way first, which is the way I've seen it done in most textbooks for most courses. So what they tell you to do is to take the value of the column, multiply it by the number that we put below it, add it to the value of the next column, multiply by the number below it. So we land up with something that looks like this. 128 times 1, whatever the answer is there, because remember BODMAS, plus 64 times 0, plus 32 times 1, plus 16 times 0, plus 8 times 1, plus 4 times 0, plus 2 times 0, plus 1 times 0. That should give me 128 plus 0 plus 32 plus 0 plus 8 plus 0 plus 0 plus 0. Which, if you quickly add that up for yourself, is 168. Now, this is technically correct. It works pretty well. But to me, this has two big problems. Firstly, in the CompTIA Network Plus exam, you do not get access to a calculator. So 128 plus 32 plus 8, it's not difficult, but hey, when you're in the exam and you're under pressure, you'd be amazed the mistakes you can make. Secondly, I kind of feel that multiplying the value of a column by 0 and then adding it to the columns that actually do represent a value is kind of a waste of time. So let me show you how I do this, which is going to obviously require a different number because we already know the answer now. So let's go for 0, 1, 1, 0, 0, 1, 0, 1, just to be different. So I've got a 0 under the 128 column, which means I'm not going to use that column. If I go and say 128 times 0, I'm just wasting my time and ink. So let's move along. I have got a 1 under the 64 column. So what I'll do is I'll write down 64. Then I look to the next column and I see, oh, I've got a 1 under the 32 column. Let me put 32 and add it to 64 now. So I've got 64 plus 32, which again, remember in Network Plus, you don't get a calculator. So if you need to do some simple arithmetic tricks, it's fine, but it gives you 96. All right. Now I've got a 0 under the 16 column, so I'm not going to waste my time or ink. I've got a 0 under the 8 column. I'm not going to waste my time or my ink. I do have a 1 under the 4 column, so I'm going to say 96 plus 4. That gives me 100. Now I've got a 0 under the 2 column, so again, I'm not wasting time or ink. Let's move on. And I've got a 1 under the 1 column, which means 100 plus 1, and that gives me 101. Fantastic. So now we can go from binary to decimal pretty easily. But what if we want to go the other way around? What if we get given a decimal value, like 172, and we want to work out what that looks like in binary? Well, I've got a method for you here, but it's going to be a little bit weird and confusing. So what I'm going to do is I'm going to look at the value of a column, and I'm going to ask myself, could I subtract that value in the column from the decimal value there on the left-hand side and get to 0 on the left-hand side in decimal? If I get to 0, fantastic. If I don't, okay, am I going to be getting closer to 0? In which case I'm happy with that as well. Because by the end of the table, I want to have reduced that decimal value on the left down to 0. I don't want to go into a negative number. In all the years I've been doing networking, which is many years, I have never seen a negative IP address. And if I haven't seen it by now, I doubt I ever will. So let's play with it, and hopefully that'll start making a bit of sense to you with what I just said. So if I take 172, I could subtract 128 from it. And that should leave me with a value of 44. So, okay, I'm not at 0 yet, but I'm very close to it now. So I'm going to put a 1 under the 128 column, because obviously I'm going to use that. Then 44 minus 64. That puts me at minus 20. I don't want that. Remember what I said, I don't want to land up with a negative number, because there is no such thing as a negative IP address. So I'm going to put a 0 under the 64 column, because it's going to put me in the wrong space. All right, so let's erase that and try another value. So 44 minus 32, oh yes, that should work. It gives me 12. So I'm going to put a 1 under the 32 column, because I'm going to use it. Now I've got 12. If I were to say 12 minus 16, that's going to put me into the negative. So not wasting my time, I'm just going to stick a 0 right there now before I even move along. Next column's value is 8. 12 minus 8, that will work. That gives me 4. So I'm going to put a 1 under the 8 column. And then I've got the next column's value, which is 4. Yay. So 4 minus 4 gives me 0. That's what I was after. So I'm going to use the 4 column. But now what do I do with the 2 and the 1? Well, just like with decimal, if I don't need those columns on the right-hand side, I just stick a 0 there and a 0 there. Done. Fantastic. Let's do another example. One that will make us work. But this example is actually going to save us time, and you're going to see why. So 255. This is going to be a lot of subtraction. 255 minus 128, that should give me 127. So I'm going to put a 1 under the column because I want to use it. Now, 127 minus 64, that works. It gives me 63. So I'll put a 1 under the 64 column. 63 is now left. 63 minus 32, that gives me 31. So I'll put a 1 under the 32 column. 31 minus 16, that gives me 15. So I'll put a 1 under the 16 column, so I'm using it. Now I'm on the next column, which is 8. So 15 minus 8, that gives me 7. So I'm going to use that column. And now I'm running out of space on the screen here, so just give me a second. Let's just move a 7 up here so we can keep working. Let's see, 7 minus 4, that works. That gives me 3. So I'll put a 1 under the 4 column. Now that I've got 3, 3 minus 2, and that gives me 1. So I'm going to use the 2 column. And 1 minus 1 gives me 0. So I'll put a 1 there. Fantastic. Now, if you ever find yourself in a situation where you've used all your columns up and you still got a number in decimal there. One of two things have happened. You've either made a mistake, which is okay, just go back and figure out where the mistake is, or you're trying to deal with a number bigger than 255. If you're dealing with anything larger than 255, you need at least another column. But here's the cool thing. I have just given you guys a shortcut because 255 is 8 binary ones. Now, in a later video, when we go and play around with subnet masks, and I ask you to put 255 in binary, instead of doing all this arithmetic, you now know it is 8 binary ones, and I'm completely fine with that shortcut. All right, so now, guess what? You can all go back and forth between binary. How great is that? Now, a bit of practice will definitely help a lot. But I promise you this much, with some practice, you'll get used to this, it'll be easy for you, you might even be able to do it in your head. Now let's look at hexadecimal. Hexadecimal is going to be quite useful to us because it is used for our MAC addresses on our network cards, and it is also used to represent IPv6 addresses in as user-friendly a way as possible. So let's understand this. It is called hexadecimal. So hex being 6, dec means 10. This is 16 values. And we count from 0 to F. Don't worry, I'm going to show you the values now. So our values are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And if you're looking at this going, wait a minute, those are numbers, and those are letters. I'm not going to disagree with you, because that's what your parents, your teachers, etc. have taught you. But I want you to think slightly differently. Stop thinking about those as numbers and letters, and start thinking of those as symbols, because that is what they are. They are just things that we write that represent a value. Like, if you look at the numbers that you and I recognize as 0 through to 9, and go back in time and show that to an ancient Roman, they will ask you, why are you showing them Arabic script? Because that's what that was to an ancient Roman. They used the I's and the V's and the C's and the X's for their numbering system. So it's just a symbol that represents a value. Okay, cool. How are we going to work with these values? Well, what happens is each of these hexadecimal values that you see here is going to represent a 4-bit binary value. And all we do is a simple substitution method. If I see a particular hexadecimal value, I can substitute in a 4-bit binary value. Cool. Now, again, for exam prep, I suggest you jot down a table. Remember, you get that scrap piece of paper in the exam. And what you want is a column that does binary. You just need 4 binary bits, a 1 column, a 2 column, a 4 column, and an 8 column. And then you do hexadecimal from 0 to F. I've put the decimal there on the far left just for some context, just so you can keep track of, oh, okay, if I see D on its own, that's like decimal 13. But you want to jot down a binary value of 4 binary bits. 0000 is hexadecimal 0. 0001 is hexadecimal 1. 0010 is 2. 0011 is 3. 0100 is 4. 0101 is 5. 0110 is 6. 0111 is 7. 1000 is 8. 1001 is 9. 1010 is A. 1011 is B. 1100 is C. 1101 is D, and 1110 is E, and finally 1111 is F. Now, as I said, this is a simple substitution. So let's take a MAC address from a computer and play around with it. So this MAC address is D8C0A63680F9. Let's quickly rewrite that now so that we can play around with the numbers. And what we're going to do is this. Every time we see a hex value, we'll put in the corresponding 4 binary bits that it's meant to represent. So D is 1101, 8 is 1000, fantastic. C is 1100, and well, 0 is just 4 zeros. That one's nice and easy. A is 1010, and 6 is 0110. 3 is 0011. 6 is, again, 0110. 8 is 1000. Another 0 there, so 4 zeros. F is 4 ones, and 9 is 1001. Fantastic. So now we've got our MAC address written in binary. Just rewritten it there for you, so it's a little bit more congruent with how it normally appears on your screen, but lovely stuff. Now, if you're looking at the table and thinking, but how am I going to get that binary value right? Remember what we said. It's a 1, a 2, a 4, and an 8. That straight away should allow you to be able to quickly put together a conversion table and work it out. Or, if you're crafty, you could notice there's a pattern. The rightmost column represents 1, and it alternates every one row. 0, 1, 0, 1, 0, 1, 0, 1. Second column from the right represents the value of 2, and it alternates every 2 rows. 0, 0, 1, 1, 0, 0, 1, 1, so on and so forth. The next column, which represents the decimal value of 4, alternates every 4 rows. 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, rinse and repeat. And finally, the last column that represents the 8 alternates, you guessed it, every 8 rows. 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, and obviously that's done now. So you can use those little patterns that you notice to help you out. Otherwise though, that was a number conversion video. So firstly, I'd like to say thank you for watching. I really appreciate it. If you have any friends, family members, colleagues, or peers that are also looking into doing Network Plus, share this video with them. And before you go, don't forget to subscribe. Otherwise though, I'll catch you in the next video.